Hello my students, this is lesson 1, part 2, motion in one direction. As we know before, we have two types of speed, regular speed and irregular speed. It's difficult to know the amount of irregular speed, so we can use another term which called average speed. What is the meaning of average speed? The average speed, it is the total distance covered by the moving object divided by total time. All the distance that the object moves divided by all the time, okay? That's used to cover this distance. So what is the rule that we can use to measure the average speed in problems? Total distance divided by total time. Total distance divided by total time. As we see, D over T. Total distance over total time. Okay? From the definition, we can get the rule. Total distance divided by total time, and the rule is total distance divided by total time. Here we have example. Calculate the average speed of an object that cover a distance 84 meter in 12 seconds, then 56 meter in 8 seconds, then 28 meter in 4 seconds. To calculate the average speed, you must write the rule. Average speed equal total distance divided by total time. So we will have 84 plus 56 plus 28 divided by 12 plus 8 plus 4. All the time in our problem and all the distance in our problem. Okay, so the average speed will equal 7 meter per second. Okay, let's go to another type of speed. We have the relative speed. The relative speed, the measuring the relative speed depends on the position of the observer. The person that stands, the person that can observe the car, the person that sees a car. Okay. So the relative speed is the speed of the moving object relative to a constant or observer. In the definition of relative speed, you must write relative to observer. The observer here, or the person here, or the car here will determine or will know the speed of the car according to itself. Okay? Here we have the first case. If the observer is at rest, someone is standing. Okay? The relative speed here will equal to the real speed. What is the meaning of this? If the speed of the car is 100 kilometers per hour, the observer which at rest, the standing one, will see it 100 kilometers per hour. He will see the speed of the car as it. The car will not be fast or will not be slow. It will be as it. If his speed is fast, the observer will see it fast. If the speed was slow, the observer will see it slow. Okay? If his speed is high, 100, I will see it in 100. If his speed is 0, I will say it is 0. Okay? So when the observer at rest, the relative speed will equal to the real speed. This is our first case. The second one, if the observer is in opposite direction of the moving object. Okay, if I am in the car and another one in another car. Okay, if I see a car come in opposite direction of me, I will see it will be faster and faster. Okay, so the relative speed here will be more than the real speed. So the relative speed here will equal real speed plus the observer. Okay, so the observer, me, will see the car at very high speed because it's in opposite direction of me. Okay, let's imagine if the speed of the observer is 60 and the real speed of the car is 100. Me, the relative, I will see it 160. I will see it more. Okay, it's real is 100. But because it is in opposite direction of me, I will see it higher. I will see it 160. Other case, if the observer in the same direction of movement of the moving object. If we are in two cars and we are in the same direction, I will feel that the car is less. It's literally slow. Okay? So the relative speed were less than the real speed. So the relative speed here equal rail minus observer. So the observer will see the car at very low speed. Okay, if we are in the same direction, I will see it in very low speed. So if the speed of the observer is 60 and the real speed is 100, I will not see it 100. I will see it 40. Okay, I will see it less than its real speed because we are in same direction. The last one, if the observer is moving in same speed and same direction. We are inside two cars, okay? And we move in same speed and same direction. I will feel that the car beside me is static, is at rest. It doesn't move. I will feel it. I will feel that. Why I see its speed is 0? Because we are in same speed and same direction. So the relative speed here will be 0. I will feel that the car doesn't move. Okay? At rest, static. So again, if I say in opposite direction, I will see it higher speed. The relative speed will be high. I will make plus. Same direction, I will see it is very slow. So I will make minus. The relative speed will less. If we are same speed, same direction, I will see it 0. I will see it rest and doesn't move. Thank you for watching.